episode of our daily dose of LeetCode, where we do LeetCode for about an hour, talk about some new things, go over some questions, make some mistakes. You get to hear me struggle, and hopefully we come up with an optimized algorithm at the end. So we'll just do a quick introduction like we always do. I know I'm slightly late. It's been a little bit of an interesting day, but that's all good. I went to my first jury duty session today, which I thought was pretty cool. Of our daily find out a little bit more about the judicial system, which I guess doesn't happen a lot. I'm 29, and at 18 you're eligible to go, so I pretty much evaded it for 11 years. And it's pretty cool because this first one, I was there for a very long time, and they ended up just excusing us, so I didn't really do anything. But I thought that was like a pretty, I guess, sort of interesting way to spend my day. We'll see if I'm summoned again next year, or maybe I have to wait another 11 years. So I know I've been making some posts around the internet regarding the daily dose of LeetCode stream. So hopefully some of the people watching today are from the places where I've made those posts. I won't really publicly announce them here. Maybe at some point I will. I think just for now, no. But yeah, so without further ado, let's just go ahead and get started. We're at 74 questions right now, which means we're only 26 away from getting to our 100 question milestone, which I think is pretty phenomenal. I had a friend of mine on the Discord I run reach 100 hards today, and we'll definitely get there with time, just like we have been doing so since we started last week. So like I always do, we're going to start with the easy questions. So we'll go to algorithms, easy, we'll sort by acceptance, and now we'll just start scrolling all the way down to where we last left off. So here we go. We're going to start today off with find target indices after sorting the array. And let me actually, I want to keep some metrics up since we start all this. Just give me one moment so I can get a little bit of a better view of the stream itself. So content, actually on my other monitor, I have sort of like the stream information coming along. Okay, sweet. All right, so let's keep it going. So find target indices after sorting array. So we're given a 0-indexed integer array nums and a target element target. A target index is an index I such that nums I equals target. Return a list of target indices of nums after sorting nums in non-decreasing order. If there are no target indices, return an empty list. The return list must be sorted in increasing order. Okay, so if I do 1, 2, after sorting nums is 1, 2, 2, 3, 5, nums indices where nums of I equals 2 are 1 and 2. So we return 1 and 2. Okay, and it says in non-decreasing order. Increasing order and non-decreasing. This is strange, right? Because increasing is non-decreasing. So it wants us to sort it. It looks like we should first sort this input array. So I'm going to not do this one since we kind of see the answer here. But imagine we took this one and sorted it. So we'd have what? 1, 2, 2, 3, 5. Which I guess is the same example from the first one. And we're looking for 3. So only the index where nums of I equals 3 is 3. But they just want us to return nums of indices where nums of I equals 2. Given a 0-indexed integer array nums and a target element target, a target index is an index I. Such that return a list of target. I feel like there's got to be like a trick to this because 1, 2, 2, 3, 4, and we're looking for 5. This is 4, 0, 1, 2, 3, 4. I can't imagine that we have to go through. I almost feel like, okay, there's like a couple different ways that we can do this, right? The brute force method really is to sort it. Do we really even need to 1, 2, if I'm looking for 3, this comes in 3, okay. Well, let's go ahead and sort it. So we'll have sorted nums equals, we'll create a copy of nums by doing the spread operator. And then we'll say sort A, B, A minus B. We'll have our result for let I equals 0, I less than sorted nums dot length, I plus plus. I think definitely did not want to delete that much. Do this, I plus plus. And then we say if sorted nums of I is equal to target, then result dot push I. return result. This is what I believe to be the brute force method. Let's see what this gives us. Let me just open up this here. Okay, sweet. Let me also, I need to go back into my YouTube channel again for one moment. I'm gonna go to Studio because it's good for me. It's good for me to see like the analytics of the stream. That's just like good for me to know. And we've been going, there's another mode. Oh, you know what we can do? I think if we do go live, there you go. Okay. And it might say that we already have one going on. Okay, yeah, we've been going for 5 minutes and 30 seconds. Okay, great. I just want to make sure that I have like the stream connection set up properly. Okay, so here we get 1, 2, 3, and 4. So if we submit this, okay, so this does give us the right answer. However, let me see. Could we do this? Could we do this any faster? My thinking is yes. And why is it that I think that? There could be empty list or return list must be sorted in increasing order. So right now this is a linear algorithm, right? But what if we found, is it possible just to find every index? Can we use like binary search to find every index where this is true? I don't know if that would be like a modified binary index, not binary index, or binary search. Or what if we just found, after sorting nums 3, output 3. So here it says we're looking for 3, so we find 3 after sorting it. Here we're looking for 2. So what we might be able to do, so imagine worst case, every single, like imagine this is 5 and we're at the end. We'll have to go all the way to the end to find 5. But what if I just found the first one? What if I found the instance of the first number and then just looped over it while the numbers were the same? That could be one way of doing it. Or maybe finding some range where like we say, looking for the first instance of 2 and the first instance of 3, something like this. Like the first instance of that one and the first instance of the next one. That might make things a little too complicated, but we can definitely try to see if we can get the first one. So how would that look like in this case, right? Let's say we did a binary search here. We had I and J, and then we have our middle being here. Like we can say, okay, mid is equal to target, but if we're not at 0, and the one previous is the same number, then let's think about this. Because I don't want to return that midpoint yet. Because what if we also get, we get something like 3 2s, right? So we find the midpoint, so 0, 1, 2, 3, 4, 5, 6 divided by 2 is 3. So this would be our midpoint here. 0, 1, 2, 3. Is there like more that we can look for? Yes. So maybe at that moment we make J equals to M. Maybe J equals to M. And what if we calculate this again? So 0, 1, 2, 3. 3 divided by 2 is 1.5. That's 1. So M is now this. If M is not 0, or like we can keep looking as long as M is not 0 and M minus 1 is the same number. I think that's something that we could do. So what if we said let me kind of just like remove all this. We're going to sort of have like a modified binary search here. What if we did like find first, or we said first index equals 0. Maybe we can have start equals 0, let end equals nums.length minus 1. Here we'll have while start is less than or equal to end. Let's also declare our mid. We'll declare it but leave it undefined. Here we can say mid equals math.floor of start plus end divided by 2. So here we say if mid, so let's see, if mid is greater than 0 and we have nums at mid minus 1 is equal to target. I think here we can just do, I'm fine with saying end equals mid here. Else if what? What if we end, what if we're looking for 5? What do we do? Or if it's lower, right? Else if nums at mid is less than target, then we can say start equals mid plus 1. Start equals mid plus 1, because we're already accounting for mid. And then at the end, so end equals mid. So if mid is greater than 0 and nums of mid minus 1 is equal to target, else if, I guess we can also have if mid is greater than 0 and it's not equal to target. So let's see. Let's kind of abstract this. If mid is greater than 0, here we say if nums.mid equals target, end equals mid, else, maybe here we just return mid. Trying to see like how we can, so we have our start, we have our end. This is going to be 0, 1, 2, 3, 4, 5, 6 divided by 3. So this will be our midpoint here. Okay, so if mid is greater than 0, which it is, if nums at mid minus 1 is equal to target, then end equals mid. So now we're here, end equals mid. Okay, so 0, 1, 2, 3. 3 divided by 2 is 1.5. And then floored, so we have our middle of here. If mid is greater than 0, which it is, if nums at mid minus 1 equals target, else, okay, we just return mid. Now, what if we're looking for 1? I need to go through a couple of different test cases here. If mid is greater than 0, if nums at mid minus 1 equals target, which it doesn't, then return mid. Yeah, I need to modify this a little bit better so that we're not just, I think here it's a case of like coding too quickly. Let's do this. I'm gonna nuke it. We're gonna nuke it. We're gonna start over. So what's my plan? Let's go over the plan, right? 1, do a modified binary search to find first index. Search from there, which only, it just gets us further into the array. I guess it'll be log n plus n. So that might still actually, the bottleneck might still end up being n. So is that even worth it to try? I mean, I think the exercise of finding the first index could be good. I almost want to do this just to find the first index of a number after sorting it. All right, so we have a couple different cases. Let's say target equals 2. First, nums at low can be less than target. What do I want to do here? I need to go higher up, right? So my low, nums at mid, if nums at mid is less than target, low is equal to mid plus 1. If nums at mid is greater than target, right, we have high equals mid minus 1. If nums at mid is equal to target, let's see, and if it's equal to target, we want to make sure that we're not at 0. What happens if it is equal to, if it's equal to target, there's like two things we can do. We're either at 0, if we are at 0, return mid, else if nums at mid minus 1 equals to target, then we can say high equals mid minus 1. Is there any other cases? If nums at mid equals target, if we're at 0, we can return mid. If nums at mid equals target, high equals mid minus 1. Else, if it's not equal to target, this is the part that I'm getting a little bit confused on, because I think there's another test case here that I'm just not seeing. So what are the different cases, right? If, let's say it's like, we're looking for 2. Let's do 2 here to make it easy. If my midpoint's here, I say, okay, mid is equal to target. We're not at 0, but the next one is less, so I want to keep searching lower. If we're at 0, for example, if this is 2, I just return mid. Now, if I have this, equals if mid equals target, I guess here we can also return mid. Because it's not, if it's equal to 0, we can return mid. Or, so if mid equals 0, or nums at mid minus 1, not equal to target, here we can return mid, right? Else, if nums at mid minus 1 equals target, here, if nums at mid minus 1 is equal to target, then we do the high equals mid minus 1. High equals mid minus 1. So I think this is sort of what we can do here. So let's now try to do const sorted nums is equal to, we're going to do a copy of nums using the spread operator. We're going to use the sort method, a minus b, which in reality, this is really the bottleneck, right? Because we have to sort this. This now becomes an n log n algorithm time-wise. So sorted nums equals this, a minus b, and now we can start doing low equals 0, let mid, I'll just set this to 0, and then let high equals nums dot length minus 1, while low is less than or equal to high. Mid equals math dot floor of low plus high divided by 2. Here we can say if nums at mid is less than target. This is like similar binary search stuff. Low equals mid plus 1. Else if nums at mid is greater than target, we can say high equals mid minus 1. Else if nums at mid is equal to target, which I guess we don't even really need this, right? Because that's the implication. If it's not less or greater, it must be equal. Else, here we can say if mid is equal to 0 or nums at mid minus 1 not equal to target, return mid. If nums at mid minus 1 is equal to target, high equals mid minus 1. So is it guaranteed that we're going to have, if there are no target indices, return an empty list? So I guess really at the end here, we can just return, let's just return an empty list because we didn't find anything, or we can return mid. I just want to see what this is going to do. Is this going to give us, we can return mid here. That's finally when we found it. Now is this gonna, let me make sure this first runs without it like breaking. Okay, so not a valid value for expected. Okay, that's fine. It wants me to return an array, so let's just do this. One, two, okay, output is empty here, and then expect, oh, wait a second. I kept doing, it should be sorted nums and not nums. Like anywhere that I'm using nums here, sorted nums, sorted nums, sorted nums, sorted nums. Let's try this. 1, 3, 4. Oh, this is great, right? This is great because now we have found, okay, so now we have found, like if you look at this, it matches up with the output 1, 3, 4, 1, 3, 4. So really what we can do from here now is once we're going to return mid, like right here, we're at the midpoint. So we can essentially say, we can say const result, set this to an equal, or set this to an empty array. We can return result on here in case we never get a chance to set it. And then right here, we can say for mid less than nums let's say sorted nums dot length mid plus plus if, let's see, if sorted nums at mid is equal to target, we'll do result dot push mid. Right, so we'll keep doing this, or even better, I only want to do this. You know what? Forget the for loop. We can even do better here. We can say do while sorted nums at mid is equal to target. Right? This should let it stop on its own. Sorted nums. No, here we just want to push mid and mid plus plus. So let's do that. Right, because we know this starts the mid, and then if we run this, okay, so let's see. While sorted nums at mid is equal to target, return result dot push mid plus plus. Does it not check this after? While sorted nums mid is equal to target. Oh, and then we need to just return result here. One, two, three, four. Okay. Looks like we have that piece right. So let's run this now. Okay, 44.38. So good. Okay, so what did we learn from this, right? We essentially figured out how to do. We figured out how to do a modified binary search, which frankly I've never done before. But this binary search, what it does is it helps us find the first index of a number if you have duplicates in a sorted array, which I think is pretty neat. Because before, think about it. If you had this sorted array, like so, imagine here you have your 1, 2, and then this is sorted to what? 1, 2, 2, 3, 5. Like imagine you're looking for 5, so 0, 1, 2, 3, 4, or even for 3, because this one would never happen. We would have to traverse this array all the way. We'd have to iterate through the entire array before getting to 3 to be able to print it out. But with our method, we find the index in log n time, and then we only need to move forward from there. So I like that. I'm pretty happy with that. Let's submit it a couple more times and see what the performance ends up being. This is 66.43. I'll compare it with some of the other ones that we did. $72.5. So I feel like it's definitely better. Let me see what discussions are talking about. Let me also go here. Okay, sweet. So is this not like O of n single loop count, O of n time counting sort, count smaller and equal, 4 different ways, binary search, counting sort. So what is this one? One iteration to count less than target and equal target. Build output based on the first index at less than. So int count equals 0, less than equals 0. If n equals target, we increase the count. If n is less than target, we do less than. And then here, for int I less than count. So what is count? Oh, this is how many. Okay, result.add less than plus plus. Good job. This is really clever. Why this worked exactly. Okay, for 144225, for 4, count occurrence of 4, 2, and occurrence of elements smaller than 4. You'll get 2 and 3. That means index of 4 in a sorted array begins at 3 because there are 3 smaller elements in front of it, and ends at 4 because there are only 2 occurrences of 4. Yeah, that is very clever. Again, my stance on this is absolutely learn it. There's no reason not to learn this. If you end up like whipping out something like this during like an interview, I think that's definitely like super cool. But I'm also happy with our thing because I know for sure that being able to find the first index of an element in a sorted array, I think that's going to be like a medium question later on. So we effectively maybe learned how to do something medium-ish. So that could be cool. Awesome. Yeah, by the way, I would love to, hear what you all have to say. If you guys have any questions, comments, you guys want to just hit me up and talk to me on chat. That'd be pretty cool. We'd love to communicate with the community. That'd be awesome. All right, so the next one here. Generate a string with characters that have odd counts. So here we have a terrible like to dislike ratio. Given an integer n, return a string with n characters such that each character in such string occurs an odd number of times. Okay. So we're going to return given an integer n, return a string with n characters such that each character in such string occurs an odd number of times. So n equals 2, x and y, n equals 7. So we can return any characters, but they always need to add up to this one. Okay. I wonder if I can just do, if I have like a 7. Let's see, let's think about this. If we have a 7 here, well, actually, was that the last one? 7 is olas. We have 1, 1, 1, 1, and then 3. I mean, we can pick just a string? A number of times? If there are multiples, valid strings, can't we just return 3 times? Note that there are many other valid strings, such as LOVE. Wait, can we not just return every character once? Can I just generate, like, what if we just, what's like the easiest way to, okay, we're gonna do something crazy. We're going to do something very crazy here. Let's do const result for let I equals 0, I less than n, I plus plus, const char equals string dot from char code I plus 97, result dot push char, return results dot join. Because can't, like, every ABCD, right? Like, as long as everything appears once, 1 is odd. AB, A, B, C, D, F, G. Like, wouldn't this work? Whoa. Expected A. A. Wait. Okay, I completely misinterpreted this question. Why is it that we have, if I have, oh, I see. It's only lowercase English letters if there are multiple valid. So can we just use, we can use each one of them once. Let's see. We can also just use each one of them like multiples, although this is gonna be 500, right? So at some point we can do like 1 1 1 1 1 1, and then the next time we'll do 3 3 3 3 3, and just sort of like keep adding it like this. It doesn't even need to be A. Or can we just always add 1? Like if it's even, if it's an even number, if it's an even number like 6, we can just divide it by, oh, that wouldn't work. So I was almost thinking like, we can always add, yeah, we can always add everything once. And after that, do we just add everything 3 times? What would be the best way for me to say like add this character 3 times without having to like build the character every single time? Because that just sounds not good. Many other valid strings, return any of them. I guess they picked one of each. So they're like, okay, it's a 7, so let's pick 1. So if I'm at 500 and I pick 26 of them and I go back, I can't add another one because then that means there's an even number of them for each one. But if I'm at 500 and I say 500 minus 1 is 499, so how many A's can I add? I can add 499 A's and then just add one more to make it odd, right? Like if it's 2, okay, so if it's even, right? If it's an even number, we can add like minus 1 equals 499. I can add 499 A's and then just 1 B. If it's already an odd number like 3, we'll just add the character that many times. I think that's the easiest way of going about it. Here we can do, yeah, I think that's the best way. Although it seems like a lot. We'll have to, well, I guess we'll have to go up to n, but that does change with the size of the input. We can still do this, and then let's just always add, let's just always add 0. Less than I less than n minus 1, or let me see. Here, I got one even better. We can do let result equals new array. We're gonna fill this up with, let's get, no, okay, here we go. Let fill amount equals n divided by 2. If that's even, it'll be n minus 1, or it'll just be n. Okay. So we'll say fill amount. We'll fill this up with the fill amount. We'll create a new array with fill amount being whatever it needs to be. Here we can fill it with string dot, and I'll just kind of put this on a new line. String dot from car code 97. That'll just give us all A's. And here we can do the same thing. If n divided by 2 equals 0, or if fill amount, no, it should always be n. If n divided by 2 is 0, that's an even number. If it was n minus 1, we can just return result, because this would have been made odd. And if it's odd, no, if it's even, we should add one more to this. We should do result dot push string dot from car code, and we'll do like 98. And then at the end we can just return result. Let's try this out. And I also want to copy this crazy, 427. Here we have 78. Let's go over this. Oh wait, I don't want, we also have to join it, which isn't, I'm not in love with that, but if we're just going based off the algorithm here, maybe A, B, A, and then we have A, B. All right, so let's go over this. If this thing, we figured out, like if it's even, like if it's 500, right, then we can just add the fill amount 499, because that'll be odd, right? Or we can just do 500. And then at the end, if it's odd, or rather if it's even, then we'll just push one more to get it back to odd, or we'll just return the result as is. 71.02. So a very weird algorithm. This is not like a question that I would expect to see anywhere really. Can we actually do a little bit better here? I think we should just, I think what we can do, let's see, if n divided by 2, right, else here, let's just return this. Return new array of n, dot fill. We'll create our new array there. Else we can do the same thing. I deleted too much. We'll do the same thing. This is just like to clean it up a little bit. Const result equals new array n minus 1, and then we'll do the same thing. Result dot push. Here we'll do 98. Return result. Let's try it again. And we're still doing, and I guess we're gonna have to do this down here as well. Let's run this. AB, A. A little bit cleaner, but I suspect we'll still get the same. Let's see the discussion. I feel like there's gonna be a very easy way of doing this. One line. If n is odd, we return this. Repeat. Okay, yeah, return b plus ab substring. Repeat n minus 1 times. Very similar to what we did. I would never expect to see something like this in a programming interview, so no need to worry about that really. Find greatest common divisor of array. Find the GCD. Right? Find GCD. Given an integer array nums, return the greatest common divisor. The greatest common divisor of two numbers is the largest positive integer that evenly divides both numbers. The smallest number in nums is 2. The largest number in nums is 10. And is this sorted given an integer array nums? Okay, it's not sorted, which I don't think we necessarily need to make it sorted. We can loop through this and just sort of like find the min and max ourselves. Now the largest that, like if we do 3 and 8, the GCD, is there like a good way of doing that without starting from the number and just going down? I feel like there's a constant time operation to find the GCD. Is 2, is 1, smallest and the largest is 3. 3 and 3 is 3. So if I were to get the largest and the smallest number in nums is 3, largest number in nums is 2, the greatest common divisor of 10 and 2. So if we start at the lower one, or I guess, is there anything 3 and 3? Well, is it just going to be the minimum? The greatest common divisor, like if, no, because if it's 10 and 50, oh no, yeah, it would just be the minimum, right? Wait, return math.min of nums. What? I don't know if this is the answer, but that would be funny if it was. Okay, 2, 3, 3, that's not. 2, 3, this is 1. Oh, okay, 3 and 8 now. So you can have some that's even smaller. Now, can it ever be bigger than the lowest one? No, right? Because 3 doesn't divide to anything. So we can just go up from 0. I guess 0 up to 3, always taking the math, or the max. So if I find the minimum, let's see if that works. Const min equals math.min of nums. But then we also need the max. Const max equals math.max of nums. For let I equal 0, I less than min, I plus plus. Let's say GCD is 0. GCD is equal to 0. If min, carry on, Raphael. I'm just lurking. Oh man, that is so, man, Tony, thank you so much for writing something in the chat. That is so cool. I'm really happy. I know you're one of the newer subscribers, or if not a subscriber, I know that you've commented recently. So that's so cool to see you on Stream Chat. Really appreciate you joining in. Thanks so much for joining in. And yeah, let me know if you want to see anything specific, or if you feel like you have questions about anything that I'm working on. Feel free to let me know. I'd be more than happy to like explain myself or dive deeper. And hopefully in the process, I'll also learn something. So that's super cool. Hopefully you benefit from this, and I'm excited to have you on board. So let's keep it going. What if here we did if min, like we want to find like if min modulo I is equal to 0 and max modulo I is equal to 0, then we can do GCD, or GCD equals math.max of GCD and I. Now, should this also go, this should go at least less than min. Less than or equal to min, and max is equal to I. So then here we can just return the GCD. Again, I think there's probably a faster way of doing this. 213, 213. Okay, 61.85. So what did I do here? Like, we got our min and max. Both of these are linear time operations. So this is 2 of n, which just converges to n. And then I start at 0, which maybe, I mean, I guess if it's like 0, 0, 0, will any of this ever be 0? Okay, I think I can probably just make this 1. For let I equals to 1, I less than or equal to min, I only need to go up to the min because the greatest common divisor, the greatest common divisor needs to be less than the min, because 3 is not divisible by like 4 or 5, right? At least that's what I think. Maybe my math is flawed in that sense, but that's the logic I used here, and apparently it's right. So I'm happy continuing on that way. So I less than or equal to min, I plus plus, and then I just check that if both min and max are divisible by the current number, then we'll just take the max of the previous GCD and I, which I believe I can make both of these 1. I'm just going to go ahead for the submit and see. 89.54. So I mean, it seemed like much faster than the previous one. But I'm also going to look up like the formula for this. GCD between 2 numbers. There's got to be, I bet you there's like a, is there really not like a constant time? Oh, here we go. Euclid's algorithm. 8 times, oh, and then the least common multiple. Okay, that's not. How do you find the GCD between 2 numbers? Find the product of A and B. Find the least common multiple of A and B. It's greatest common divisor. Easiest way to find the GCD. It's 10 to 10 minute question. 10-minute video. Let's see what discussions have to say. Python solution based on Euclidean algorithm. Does this also use the Euclidean? Oh man. See, like, okay, I think this person obviously like very high reputation. People love him, but this here is not teaching you anything. Though I will say, in terms of practicality, 100% A++ on practicality, but you're not learning anything. You're just using a built-in function to do it. So Euclidean algorithm, if you can spit that out, yeah, Euclidean algorithm must grasp. A and B equals B modulo A and A. Let's see, this one seems to maybe be better. Number theory. First, we divide the bigger one by the smaller one. Repeating the trick. Lastly, since 6 is a perfect multiple, so, you know, if you knew the Euclidean algorithm, that would probably give you brownie points. Personally, if I was on the interview panel, which I have been before, I wouldn't, like, if everything else was equal, like if both candidates scored perfect or close to the same, and one person knew the Euclidean algorithm, maybe I would pick them over the other person, but there's so many variables. I don't think you just knowing, you know, an algorithm like this is gonna like necessarily get you hired, but it's probably good to know. I personally won't spend too much time on it. So let's just continue here. All right, so counting words with a given prefix, I think is the next one. Yeah. Okay, so you're given an array of strings, words, and a string pref. Return the number of strings and words that contain pref. Okay. So we want to find two words. I think what we can do here, and maybe this is words pref is code. What if I were just to go, I'm gonna try something crazy here. Return words dot reduce of ac and val, and we'll give this a starting of 0. What we can do here is we can say if val dot slice from 0 to pref dot length is equal to pref, then return ac plus 1, else return ac plus 0. I think this will work. 2, 2. Now, is it the best way of doing it? 2, 0, 2, 0. Let's see what time has to say. I feel good about this one. 56.66. Like, what we did was, like, each one of these has a, like, I mean, you're really going to be doing the same thing. We can do this a little more imperatively by going through each word and then just having, you know, starting, like, sort of having 2 pointers on the first character of pref and the first character of the word, making sure that nothing's going out of bounds. But I think this is a okay usage of slice. Like, we can slice from 0 to however long the prefix is, and if that is equal to the prefix, we just count it. I'm expecting to see our friend substring here. You know what we'll do? We'll sort of like, is there like a better way for me to do this here? Let me see, return ac. Do I even need to return 0 here? It'd be nice if I didn't. Like, and it would just keep the previous value. Yeah, we always have to return 0. Return ac plus 1. Let's see, return ac plus 1. Yeah, I'm trying to think of like a very condensed way of doing this, which I generally don't recommend. Ac plus 0. I mean, we could do const result equals this 1 or 0, and then we just return ac plus result. Could do that. That might make it a little more condensed, but nothing crazy. 85.91. Okay, pretty happy with this one. Again, I think this is just we're going through each word, which is m, and then by n to iterate over. Like, the slice presumably takes O of n time. Maybe it might take, I know we just looked this up recently, but JavaScript slice time complexity. Abounding slice is O of n. Okay, yeah, it has to go through. So this will be just m times n, or m is the word, and then n is whatever the slice takes per each one of these different words. So I'm happy with this. I think this would be like valid in an interview setting. Sweet. Let's go to the next one. Self-dividing numbers. So a self-dividing number is a number that is divisible by every digit it contains. Return a list of all the self-dividing numbers. Okay. Every digit it contains. Okay, so let's do, I'm going to create a new function that handles that for us. And what I mean is we can say is self-dividing. Let's create a new function call it is self-dividing. This will take in a num. And here we're going to say while num is not equal to 0, we'll get the first digit, num modulo 10, if, and now we can say if num modulo digit is not equal to 0, then we can return false. And then we'll set num equal to math.floor of num divided by 10. Right, so while num is not equal to 0, we get the digit. So for 128, we get 8. And now we say if 128 modulo 8 is not equal to 0, we immediately return false, else we just keep doing this, and at the end we just return true. And now we can do the same thing. We can just go for left less than or equal to right, left plus plus. And then here we'll just say let nums equals to 0 if is self-dividing left. We can say nums plus plus, and then we'll just return nums. So let's see what this does. Doesn't like my return value. This wants me to return, oh, okay, it just wants me to return an array. Okay, so const results. Can we create, I think that's gonna be too much. If it's self-dividing, we'll just say result.push left, and here we can just return result. So yeah, it just didn't like my return value. Okay, it gave us more than we would have liked. It gave us a couple more numbers, 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 15, 21. So it did all of them. So 1 including and arrange left to right. If we ever get to a moment where num modulo digit is not equal to 0, then we return false. So is that because, like, what happens with 21? So 21 is not equal to 0. We get the digit, which is 1. If 21 divided by 1, oh, and 2 and is 0. If it's not equal to 0, 21 divided by 1 is 21, right? And then we get a 2. 2 divided by 1 is 2. Not equal to 0, return false. So that should return false if it's self-dividing of left. We start at left, which we already have here. Left less than or equal to right, left plus plus. If is self-dividing left, result.push left. So it looks like something is happening here with 21. Okay, I might be going crazy. Let's do some math. So we have let num equals 21, num modulo 10 is equal to 1, and then we say 21 modulo 1, that's 0. Okay, it's evenly divisible by 0. Okay, not 0, return false. Num equals math.floor of num divided by 10. Oh, wait a second. Is that? No, yeah, that should be fine. Num equals, let's just do this. 2, okay. Now we have a 2. 2 modulo 10 is 2. If 2 modulo 2 is not equal to 0, return false. 2 goes into 2 evenly. So why does it only break for this one? It's divisible by every digit it contains. 21 is not. A self-dividing number is not allowed to contain the digit 0. Okay, 21 doesn't have the digit 0. Interesting. 128 modulo 1. So 21 modulo 2. Oh, wait a second. They want us to do it. Oh, I know why. Const num copy equals num. We'll change num every time, but every time this happens, we should do it with num copy. If num copy divided by digit equals to 0, if digit is equal to 0, or, right, we also want to check for that case where digit is 0. Okay, that looks better. So let's see this. 89.43. So I know that this sort of algorithm here to pick off digits from an individual number, this is going to be log n time, right? Because every single time that we're always like dividing this by 10. So that will just be log of the number, and we go from left to right. So to me, it sounds like an n log n algorithm, right? So it's for every number, we're going to do a log n operation. And for space-time complexity, it'll essentially be right minus left, no? Or not right minus left, but it'll be, I guess, some O of n, where n is the amount of self-dividing numbers between left and right, inclusive. So that seems okay with me. I'm pretty happy with this. We can see what the discussions have to say. Is there like a very easy, learn some Python tricks that you might not know? Let's see, Java, C++, clean code. Okay, break, res.add_i. Yeah, it seems like they did something very similar. For every number, if n cannot be divided by any of its digit, without helper, with helper, dividing number. Yeah, it looks like pretty much the same thing that we're doing, so I'm happy with that. All right. Find n unique integers that sum up to 0. Okay, so if we have a 5, well, we know that like, okay, if we have a 1, then it should just be like, if we have 1, it should just be 0, right? Because there are no n unique integers such that they add up to 0, unless it's just 0. If we have 2, we can have -1 plus 1. If we have 3, we can do, let's see, it'd be -2 plus -1 plus 1. -2, no wait, -2 plus 1 is -1 plus -1. Yeah, that's not going to work. What if we had -2? Can we just go like back and forth? I think maybe here, I think a number line might help. Let me go on Excalidraw. Our handy dandy Excalidraw. See if we can draw a line here. So we have this. Let's just say we have a couple of different lines here. I have like -5, -4, -3, -2, -1, 0. Give me one moment to do a quick text. Let me text someone real quick. So -5, 4, -3, -2, -1, 0. And then we'll do 1, 2, 3. Oh, did I lose this one? 4, 5. Okay, cool. So I'm pretty happy with this. Can I erase here, or can I make this smaller? Oh, I don't want to. Okay, cool. So -5, 4, 3, 2, 1, 0. Let's say, well, let's say. We know that 0 is here. So for this, we want to find numbers. Like if we need 5 numbers, I know the outer bounds will always exist. So it's like -1 plus 1 plus -2 plus -2. And how do we reconcile that last one, that -3? That's not really going to work, right? Can we, if it's an even number, it's always the odd number that makes it odd, if you will. If it's an even number, we can always just take from like let's say it's 4, right? If it's 4, can I make this bigger? We can always just take, like, starting from starting from the halfway point and going downwards, we can do -2 and 2, and then -1 and 1. So we can always do something like, can I just move this whole thing? Something for like even numbers. For let mid equals math.floor of num divided by 2, mid greater than or equal to 1, mid minus minus, we can push result.push mid and minus mid. All right, so we can do that. Now what happens with 5? Right, we can still do -1 and 1, -2 and 2, but now we need like an extra number. So can we just do, and how do we get that extra number? So we definitely figured out the way to do it for the evens. So it almost seems like we can do something like, okay, do it for the evens, and if it's odd, then just do this at the end. Is there something that we can always add? Or can we leave out a number from this set? What if I do 1, 2, 3, -1, that's 0, -2 and 2, that's 0. How do we get to that? How do we get to the 0 with this one here? If I start, I feel like I feel like one of them has to be bigger, maybe. Now, how would we know? What's the midpoint of this 2? Maybe we can just go slower. We do -3 plus -2 plus 1, and then plus 1 minus 1, maybe. Let's see. I feel like we're pretty close here. 5 unique integers that add up to 0. What if we did -5 plus 4 plus, would that actually work? -5 plus 4 plus -3 plus 2 plus -1. -5 plus 4 is -1 plus -3 is -4 plus 2 is -2 plus -1, that's -3. So that's not going to work. But we are left with a 3. We need to start somewhere at the end. 5 divided by 2 is 2.5. What if I started from the top? -3 plus 2 is -1 plus 1 is 0 minus 2. I feel like we're very close here. Oh wait, okay, I want to look at this. -3, 1. Oh, wait a second. 1 is, oh man. Okay, that's what it is. I didn't realize that 0 could be included. So I think what we can do here is, let's say const result is this for let mid equals math.floor of n divided by 2, mid greater than or equal to 1, mid minus minus. We can do result.push of mid and minus mid. If n divided by 2 is odd, we can just append to 0, right? And then return result. This seems fine to me. Right, 2 plus 2, 1, okay, -1, nice. Let's do the next one. All test cases on 1, 0, 0. I think that's gonna work. Nice, 25.46. A little bit on the slow side. Let's see if we run it again, what happens here. 44.91. 54.17. Is there something that we're missing here that we can do even faster? Find the rule. Naive idea 1, now write more based on this. It spreads like the wave. 42024, find the rule. Helps explain in math. Well, I mean, this is still... Doesn't work if n goes up to 10 divided by 5, I less than n. The thing is, like, it will still be O of n for both solutions in general, like amortized time, but I feel like laugh out loud at your Python approach. Return range of 1 minus n, n2. Simple Java, flow from both sides. Keep it simple, add all values till n minus 1, and then balance it with sum. 0, 1, n equals 2. This is wrong. You fail, n equals 2. You return 0, 0, violating uniqueness. Another idea in C++. N minus 2 times n minus 2 divided by 2. Some other solutions. I think doing, let me see, start filling up from left and right, complementary values. Start minus minus, start plus plus, return res. And then we're still, this one does take account of the 0, which is nice. I like it. Sweet. Awesome. Let's see how many questions we did for today. So we started the stream, not the day, at 74. I think maybe we did 5. Oh, 80 questions. You love to see it. Okay, we're at 80 questions, folks. And I'm specifically speaking to you, Tony. I really hope you're still around. That's super awesome that you're here. We're at 80 questions. So remember, if you started at 0 questions like a week ago, then we would all be together right now at 80. And I promise you, don't get so involved in the fact like, oh, they're easy questions, they're too easy, I'm not going to learn too much. I promise you, if you do good, easy questions, you'll learn a lot from them. And I can already see how some of these carry onward into medium style questions. So it's just over the hour right now. I had a lot of fun doing this one today. I know it was a little bit late, but like I said earlier, with the whole jury duty thing, hey, I learned a lot about the judicial system in the US. You know, I was a little bit late, but I will be on time tomorrow for the 7 p.m. Eastern time stream. I'm looking very much forward to continuing to do this. I'm happy that we're getting a little more of an audience. So thanks again, Tony, specifically for joining, and whoever else watched the stream as well. And I will see you all tomorrow for another hour-long stream. Very close to 100 questions. So let's keep it going. Let's get at it together, and we'll make it happen. Hope you guys all have a great night, and see you all next time. Later.